Hey folks, happy Tuesday, hope you're doing well. Hope you had a good 4th of July, or 5th of July, or whatever day we had off, right? That's the wrong one. This one here. Alrighty. Cool, we got a couple things today. We're going to talk more about exceptions in advanced file I.O., and we'll do a little more review for the midterm next week. That's what we got on tap. Any questions about the project before we get moving too far? And fire up NetBeans while we wait. All right. Come on, NetBeans. There it goes. All right, it looks like it's open, but it's not actually open. There we go. Close projects. And let's pick it up back up where we left off here. All right, so we're working with exceptions and advanced file I.O. So instead of just using PrintWriter to print text-based files, we're looking at printing binary files, where we're actually printing the bit data, not characters. So, and you can write characters to it, but it's the bit representation of it. And we looked at how some of those files are a little smaller here. And then we looked at serializing a class. So we can make an instance of a class here. So we wrote a little class for food. I could go for some sushi again. That was good. If your class implements serializable servlets. Uh-oh, am I the wrong? Do I have the wrong title, Bill? That's my title today. Servlets is Thursday. So if you implement serializable, then your class can be written each attribute at a time in binary formats. So, you don't have to reinvent the wheel. You don't have to figure out how to represent it yourself. It will just go, which is really cool. And then we saw, we got into, oh, that's weird, Bill. Maybe a refresh? So 2454 was what I had before. You might have been sitting on the page earlier. So we use these try blocks with a catch. So you try if there's something that might throw an exception. And what you can do is you can catch that exception instead of crashing. So previously our programs would just crash when an exception happened, and we felt bad about it. And now we know there's a better way we can handle those exceptions by catching them and then dealing with it. So that's the try and catch block here, which is really cool. So we did for writing files and then reading the files, right? We can read an object, and it'll read our food object out, and then we can get the attributes of that food here. So we need to declare it, and then we cast the object that we read. So it just reads a generic object, then we cast it as the type it's going to be. And then we have that object for use, which is pretty cool. So we should have, if we look at this files view, we should have two files in here. One is our test file, one is our test binary object, and a test binary file. Right? The binary file is what we did for writing 2 billion, and the test binary object is what we did for writing food. And we looked at opening those with VS Code. Has a really cool hex editor. There's other programs that have hex editors as well, which are pretty good. So we find, documents, GitHub, guys, 2151. There we go. So here's our exceptions and file out. So we could see the files here. So I could open it with code, and I can open it with my hex editor. It's just a little add-on you can install. And you can actually view the binary data. So it says, hey, what do you want to open it with? I want to open it with my hex editor. You can see the actual hex data here. And we'll see it's telling us this is the class here, right? This food, this represents what class it is. You get some other information. There's a string in there, right? Because we had in food, we had a string for name. We had a double for cost. So somewhere in there's the cost. You can't always read it all the way back out, but yeah, here's sushi, right? That was the name. And the cost is somewhere in here, I'm sure. All right, so you can read and write our files this way, which is pretty cool. Now, someone had asked about reading and writing data with an array list. So let's give that a shot. So let's have an array list of type string. We'll say, what is this? The ingredients, maybe? Now we'll have to import array list. And then we'll make that a new one. So this dot or ingredients was a new array list. And then maybe we wanted to add some ingredients. So maybe we'll add a void add ingredient. We'll take my ingredients. Oh, we need a string ingredient. And then we'll add the ingredient. Right, this way you can like give that nice little itemized list here. And then how about a array list of type string for get ingredients. We can return our ingredients list. You know, again, that's a little bit bad, so we can do this better. We can do toArray. We do toArray, and we return a string array instead of an array list. We do that. Check can be converted to string. You can tell it it's a string array. All right, let's see if we can work with that here. So then let's add our food here. So we'll say food.add ingredient. So that has rice. And food.add ingredient has, I don't know, what do we want? Like a California roll, right? Maybe some avocado. And food.add ingredient. How about we add rice, avocado, crab, or crab with a K, right? It's usually the imitation crab. I don't know if you ever get those with real crab or not. Avocado, crab, and then what's the other thing in a California roll? The seaweed, right? How about that? The seaweed wrapper. Okay, so now we have a nice little ingredient list. We have our object output stream. We'll try and write it, and then we'll say for ingredient in food.get ingredients. We'll print the ingredient. See if that'll work for us here. Give it a run. Uh-oh. Cast exception. Okay. Can't convert our goodness. Okay. We'll just do an array list type string, and we'll just return ingredients. Again, probably not ideal to return your private attribute here, but just want to see if we can get this working here. That's not part of the example. Okay, and then we'll see what we get back out then. We get the rice, the avocado, the crab, and the seaweed. Right, for our sushi for $9.99. Not too bad for an avocado roll. Okay, and then for fun, what we're going to try here now, I'm going to comment this out here. So let's do source toggle comment. So that we're not writing the file, we're only going to read the file, just to make sure we can read it before it gets written. Right? Make sure nothing's actually happening behind the scenes here with that food object. But it shouldn't exist outside of that try block. Yep, and we get it right back out. So it should work for you with an array list. Here, I'm sorry, I forget who it asked, but I remember that was a question. When you have a class with an array list, it should still serialize just fine. Okay. So here we're going to implement the game loop. We're going to be able to serialize so we can save the state of our game. It's way easier to do binary files because you can just write the whole class. You don't need to figure out how to turn it into characters, read the characters, and recreate the classes. Right, so as long as everything is serializable down the list, you'll be able to serialize, which is really cool. All right, we okay so far? Right, so talking more about exceptions. So we did the try and catch ourselves. The other really cool thing you can do is your program itself can throw exceptions. And this is how we can maintain the integrity of our class. So if someone gives me a cost that's invalid, I can throw an exception. So I can check in here, I can say, hey, if the cost is less than or equal to 0, I want to throw a new invalid, what is it, argument? Illegal argument exception. Not the 0 or less. So if someone tries to make a food and they give me a cost that's negative or 0, I'm going to throw an exception and crash. So the food does not get created. Right? So as soon as an exception happens, the rest of the code stops running. And you can make your own exceptions if you want, but most of the time there's a built-in one for you that you need or that you can use. So we're going to try and make the food, and it might throw an exception then, which is great. So if someone tries to make a food and they give me like negative 9.99, they're going to crash. So when my program runs, I'm only catching an IO exception, so I'm not going to catch an illegal argument exception. So the program crashes. So we get to this line, the food constructor is called, we get to this point, we throw, and then we're going to see, is it caught in my catch block? And if not, it crashes the program. And we get the message, cost cannot be 0 or less. So this cool string here is just, it can be printed back out when you have an exception. Now if we wanted, we could try and catch that exception. So in our catch block, you can have more than one exception that you're going to catch here. And we can just print out the exception, and we'll continue going so that the rest of the program doesn't crash. So nothing from here to here will run, because as soon as the exception happens, we jump to the catch, we print the exception, right? We see, hey, illegal argument exception, cost cannot be 0 or less, and we continue on with trying to read that file, the binary file. Okay, and I don't think we need the hello. We can get rid of hello. Okay, so what classes can do is they can maintain their integrity with exceptions. If you give me a value that is invalid, I can throw an exception. And you either handle that exception or you crash. So it makes whoever's using your class have to deal with it. Because we need to define, well, what is a valid range for this? What's a valid parameter? What's a valid argument for my attributes here? Okay, so we can catch them, caught the exception. Now, exceptions are meant to be exceptional events. We don't want to use this try-catch handling when we could avoid it. So if you have other ways to validate, you're in better shape. Like we have these try-catch file not found exceptions. If you go and read a file and the file's not found, it's going to throw an exception. Now for us, we can write the files, right? We've got permissions. If you try and write to a location that you don't have permissions to, you'll probably get a file not found exception. But like when you're reading files, we go and read, you might get some sort of IO exception, right? We can check to see if the file exists first. like we did on our other project. Oh no, this one's still output, sorry. So we go to read a file. Right, we can check, hey, if the file exists first. Make sure we go and do it. So this was the binary files. We're not doing it that way. When we did reading text files, you created a file object, you handed the file object to Scanner, and Scanner could read. We wanted to check to see if that file existed first. So we could check, we could say, hey, if we'll make a file, this is my test binary object file, equals a new file, given all of that, please. That name. Okay, and then we can check, hey, if the test binary object file dot exists. Oh, I have to import file, sorry. Import file first. Yes. Then I can use dot exists. I can check, hey, if it exists, I can go read. If the file doesn't exist, we're not doing any of that, right? I think I could probably even give it that file. Let's see. Can I give it the test binary object file? Cool. So I can give it a file object as well if I don't want to give it the name of a string. So it's usually better to check to see if your file exists, because that will keep an exception from happening. Because you can make a file object with anything. If you try and read from it and it doesn't exist, you're going to crash. Right? And then we'll get an exception, some sort of IO exception, we can print it back out, and we'd have some trouble. Here, so let's comment that out for a second. And then let's comment out our writing of the file. And then I'm going to go delete that file. Let's go delete it. Okay, so the file's gone. So when you try and read the file, it won't be there. And we should cause this exception to run. And we'll catch it, so it's not going to crash. But we're not going to actually read anything. We'll get an IO exception. So we get a file not found exception. Test binary object.dat. System cannot find the file specified. Right? Or we can also check here. If we check if it exists first, then just nothing happens. We don't even catch an exception because we're not trying to read a file that doesn't exist. We just get no output. Right? So it's usually better to check because you don't want to rely on exceptions because exceptions are typically slow. Right? It's slower than a check to see if the file exists because it's the process in the Java virtual machine. It has to like interrupt the execution of the file and then go find the handling for it. It's got to be a little bit careful. Right? And so exceptions are done in a hierarchy with inheritance. So we saw this was a file not found is a type of IO exception because it extends IO exception. So you can catch higher level or specific ones if you want. You can have multiple catch blocks as well if you want to catch separately. You got a catch for like this illegal argument exception. We could do it this way. And we could do something, and then we could catch the IO exception separately. So if you wanted to have separate catch blocks, you can. If you're just doing the exact same thing, you might as well use that pipe to combine them and say this one or this one. But again, either one's fine. Not too big of a deal. You just make sure you catch the specific one first, and then the general one last. Because if you catch IO exception first, and then you look for a file not found exception, it's going to match the IO exception first, not the file not found exception. It checks in order that you write them in. Yep, the multi-catch we can do. Yep, exceptions that are either checked exceptions or unchecked exceptions. So things that are errors, like out-of-memory errors, are unchecked. So they could just happen, and there's nothing, not a whole lot we can do about it here. But anything that's a checked exception, we need to declare. So when we tried to do this print writing here, if we didn't have this try catch block, if we got rid of that here, it's going to yell at us and say, hey, we either need to add a throws clause or we have to try catch because this is a checked exception. So we know this exception could happen. So Java is forcing us in the code to deal with it. Either by saying, sure, we're going to throw the exception so I know a bad thing could happen and I'm okay with that, or by forcing us to use a try-catch block. That's for checked exceptions. All right. Yep, so doing our own. Good. All right, and then binary files. Yep, awesome. Reading and writing binary files. All right. So this was write chars. Oh, sorry, we're looking at comparing the character here versus the number, right? Hydration. Thank you so much, Dodo. How you doing today? I'm out already, and it's not even been half an hour. It's one of those days. Took a walk downtown before the rain started, and it was hot. The random file access. This one's really cool. So let's move to, let's do a new example here, I guess. Maybe we'll leave it. Yeah, we can just add it to the end. So I'm going to make a new file here. And we're going to look at using random access file. Ooh, Dodo, those ones are fun. Yeah. NumPy and Pandas, Matplotlib. They're a lot of fun in Python. I've heard some good things about some Coursera courses. I haven't looked into it too much myself. There's a couple of sites like that, right, that run some courses. All right, so we're going to look and see if we can write this random access file, have a little bit of fun with it. So we're going to make we're not going to do anything super large, but the idea is that if you have a very large file, when we do our reading operation, like read an object, that reads one object. Then we have to read the next object, and read the next object, and read the next object, and read the next object. Or, read so many characters, and read so many characters, and read so many characters to get to the point where we need. With the random access file, you can just say, hey, jump to a location in the file and read from here. And you can ignore all the stuff in the front. That way you have, it's not really random access, but it's like any access. You can get to anywhere you want in that file. So we're going to make a random access file. Random access file. We'll just call it a random file. Sure, why not? Equals new random access file. And this one will be, I don't know, some data.dat. And then when you create a random access file, you tell it, hey, do you want to read? Or you can also read and write at the same time, which is kind of crazy. But it's okay. So we'll try the read and write mode here for a random access file. We're going to import that, and this all needs to be in a try block. It's going to yell at us and say, add a throws clause. No, we want to surround with a try catch. And that catch is terrible. We don't want that catch. There we go. If we're going to make a file. So in read and write mode, oops. Did I spell it wrong? Spelled it wrong. Random access file. There we go. All right. Now I spelled it right. Dodo, fall and winter, I'll do Python courses over at U of M Dearborn. And then hopefully next summer, we'll do a Python course here at OCC. That's the plan. We'll offer it, and hopefully we'll get enough people enrolled to run it. I think I need to get like 15 students or more before they'll consider running it. I forget exactly what the number is. Right, so now as we're using a random access file, it's similar to the data input stream and data output stream, because it's just doing binary data in and binary data out. We can use similar methods on it here. So there are methods that we can use. So let's do, yeah, Python's a lot of fun. Take our random file and we will You can read a bunch of things, or we can write a bunch of things. So if we want to, there's nothing to read right now, right, until we've written to it. So let's write some data to it. So how about we write, let's do a couple integers. So let's write some ints. So we'll write an int for, let's just throw some numbers out there. So 42 and 87 and 109 and 12 and one more, 2000. Starborn, you got the 2000. You got 2000 in your number there, right? Oh, we got more possible exceptions when we're writing. So I want this just to be IO exception. I just want to catch all IO exceptions here, and we can just spit out the exception. Now in read-write mode, it's going to make the file if it exists. Or if it doesn't exist, it'll make a new file for us. In read mode, right, it'll throw an exception. Okay, so let's see what we get. So let's run our file. We should get a new sumdata.dat file. Sumdata.dat. Cool. Let's see, can we open that one? Open. Oh, yeah, our file got bigger here. Cool. Documents, GitHub, yes, 2151, exceptions in file IO, sumdata.dat. Open it anyway with hex editor. See, okay, it doesn't look like a whole lot. We got a couple integers here. So 2a, right, in hex is what value? Let's see. So let's open our calculator here. So there's actually, in the programmer mode, you can do hex. We can say 2a. 2a in decimals, 42. Look at that. So that's the 42 we wrote. Remember, our integer should take up 4 bytes. So in a hex editor, we see byte, 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 byte there. And if I click on it, now it's showing me, sometimes this is helpful, sometimes it doesn't work quite as you'd expect. I'll see it's a 42 as in these integers. I go to this one here, it's 87. This one here, 109, 12, and what did we get over this one here? Uh-oh, that one didn't work very well. We got an end of file. We got close. We got our 12, right, the 2000. So 2000 is going to be, oh, it ran out of data here. So 7D0. So let's do in hex 7D0 is 2000. So again, the viewer here, the data inspector is not always perfect. I pick, no, still it's confused. That's so weird. I feel like it should be smarter than that. Go that direction? Nope. I don't know. But we'll see at the 7D0. So that is the binary data in the file. Okay, we run it again. And we check out our file. Right, life is good. So we rewrote on top of it here. Let's see, what is... I don't want to restart. No. Oh, I pressed the wrong key. Sorry. I'm trying to refresh. F5 doesn't work to refresh. When you ask for equal method of 2 instances, do you mean the objects comparing 2 class values or 2 data type values like integer numbers? So Mia, it depends what you want to compare. So when you add an equals method, you're defining how you want to compare 2 instances of the class. What will make them equal or equivalent? So you can either compare some of their values, right? That's usually what we want to do. By default, the object version only gives us, are you the same memory address? So if you want to say, hey, if my food should be equal, if we have the same name and the same cost, then sure, I can add an equals method that will say, hey, do the name and cost match? So if I change this here, let's take out, well, let's change some of these numbers here. Let's do, how about 10, 11, 12, and 13, and then I'm going to take out this right for the 2000 here. I'm going to run it. So we still get the 2000. The 2000 get erased here, but we get our 10, 11, 12, and 13 values here. Because with the random access file, when you open it, you're not overwriting it by default. And we were writing back on top of it, so the writing starts at the beginning. If you want to write at the end of the file, if you want to append to it, we need to go to the end of the file. So we can do that with the seek method. So we have a way for seeking where we're going to be reading and writing from. So I can do my random file .seek, and seek is going to say, hey, what position do you want to go to? That's what byte do you want to go to? Byte 0, byte 1, byte 2, byte 3, byte, how far do we want to go? So if I know if I have 5 integers, so I want to do size of int times 5. Is it size of? Is that what it is? No, that's not. Size of, oh, integer. Size of integer? Integer. No. How do I get the size of the integer? No. Size of new integer? Is that it? No. How do I get the size of an integer? Oh, goodness. All right, let's Google. Let's Google real quick. Java seek size of integer. Size method, no. Size of integer. List size. Oh my goodness, why are none of these right? Okay. That's obnoxious. That's fine. I know an integer is 4. It's 4 bytes. So if I seek to 20, right? Then I can I can start writing again. Let's write an int. Write an int. How about then we just keep on going here? How we do like 3000. And we'll see, can I leave the original data here, and we'll add in that 3000. Oh, I forgot to close my file. My mistake. Random file close. It gets closed at the end anyway, but it's really good form. Bad form to not close it, so you should always close it. Let's see now, does our file have an additional bit of data? Yeah, so BB8. BB8. 8. No, BB8. All right, BB8. There we go. 3000. So we're able to write a 3000 at this position. Now what happens if we're to like seek 100? Well, I get a bunch of blanks. Here's my BB8. Here's a bunch of blanks. I went to the position 100 and wrote 4 bytes. So now I should have 104 bytes of data in this file. Right, in my sumdata.dat should be 104 bytes. Does it tell me that? 104 bytes. Look at that. Size of 104. Now the size is matching. Hooray. So if I want to, I could open the file for reading and writing, and I could just seek to 100, and I could read that data back out. So an int value equals random file.read int. We can spit out that value. So I can open the file, jump a bunch of bytes in with ignoring everything else there, and get out that value. So with a random access file, if you know the format, and that's kind of the trick there, you have to know what the format is, you can jump around the file. So for something like my food that has an array list that has variable lengths, I'm not going to be able to tell, oops, there it is, what the length of this object is going to be. I can't just jump around and go read things out of it here. Like, I don't know exactly what the size is, but there's my rice, there's my avocado, there's my crab, there's my seaweed. Its name is sushi. Right, there's the array list. So you can see some of the things in there, right? That's called ingredients. There's a cost. So like the data itself is kind of listing out what's in the class, so it knows how to go read it, which is pretty cool. So random access files can be really helpful if you know what's in it, because we can just jump to positions and read and write from it. Okay, all right so far? What do you think? It's not too bad? Let's take a look at the project again here. We're just expanding on our game that we wrote. Now we're actually writing the game loop and adding that serializable bit here. I mean, so it needs resources, Bill. It relies on the disk operations to do the reading and writing. So CPU-wise, no. It's really cheap for CPU to read stuff and write stuff. Memory-wise, your RAM, the more that you're reading, right, the more RAM you're going to need. But they're considered slow operations because reading and writing is much slower. Disk is much slower than RAM. Not too much slower nowadays, now that we have solid-state drives, but still slower. Or because everything has to go over the connections. Right, so the play loop to actually explore our island, interact with spaces, add friends, travel to friends' islands, save and load your game, implement serializable, write the binary objects to a file. For loading, just read the objects from the file and stick them back in their game loop. So 10 points for the game loop, 10 points for saving, 10 points for loading. So if you can't get the game to actually play, if you can just save and load it, that's 20 points there. Okay. And we're just going to continue working with, oops, that should not be a quote there, the previous code. Right, so you didn't need a new repository. If you want a new repository, I can get you a new one. Or if you just want to, yeah, either way is fine. I don't know. I can grab you one here for Project 4. Let me get that classroom link real quick. I'll grab that for you real quick. Either use your free repo or this one here. New one here. All right. Cool. Other than that, how are things going? I'm working on getting everything graded for you for the end of this week. I know we got the midterm practice to work on, and then the midterm is next week, so I won't be live. There's no stream next week. You'll have the entire Tuesday from midnight, 12 a.m. till 11:59 p.m. to hit start. Okay. So the midterm review, and this was the stuffed animal class that I had a question about. So do you folks want to do some midterm review? You can do some review. All right, cool. All right, so again, the first question will have you acknowledge the academic integrity policy for the course, as described in our syllabus. Right, open book, open notes, open internet. You may not work with other people. You may not use Chegg. right? I mean, posting something on Chegg, getting an answer, and then saying, hey, I was just using the internet is still cheating. I should not have to say that, but apparently someone didn't get the picture last semester. They didn't understand how that was still cheating. Then they had to go have a meeting with my dean. So everything you submit is assumed to be your original work unless cited otherwise. All right, so for the true falses, let's do some audience participation. What do you think? Can Arraylist store primitive types? Is that true or false? Starborn, that is false. Nope, we can't do primitive types. You have to use the wrapper class. You don't even have to cast them here, but you just make an array list. Let's come back maybe here. You have an array list here. So I can't do array list of type int here. Int is not valid. It has to be the integer, the wrapper class, integer. New array list. So it can't be primitive types, it has to be the wrapper classes here. Right? Int is no good. And it just tells me, hey, required a reference, found int. It has to be reference types. Where'd we go here? Here we go. Hey, what's the purpose of the constructor method in a class? Not really less code when we have a class. Remember, the constructor's job is to give values to all of its attributes. It creates the instance of the class. So I need to give values to all my attributes. Yeah, it initializes the object. So it gives it all of its initial values. So it gives your name a name, it gives cost a cost, it creates the ingredients array list. So the constructor initializes or gives values to all of your attributes. Right, if you're using this reference to call a constructor from another constructor, it must be the first statement in the constructor. So a constructor can call another constructor. Does it need to be the first one? Yes, it needs to be the first one. That's true. All right, a two-dimensional array list or array can be thought of as items being in rows and columns. Right, two-dimensional means it's an array of arrays, an array list of array lists. Right, with rows and columns. Yeah, that one's true. Number 6, an abstract class can only define abstract methods. For number 6. So hopefully you remember here, or look around. That is not true. This is an abstract class, stuffed animal here. Any method that has something to it is not abstract. Right? An abstract method means here's the header for it, here's the definition, but there's no code. Everything else here is actual methods. So this one is false. You can have other working code perfectly fine in an abstract class. It doesn't have to, but it can. So you can have some functionality built in that's shared, and then when it gets extended, they have to implement the abstract methods. Right, our AAA convention for unit testing, arrange, act, and assert. And number 8, if you're creating a copy of an object, you want to ensure you're creating a deep copy. Remember, the deep copy means that I'm going to get new values, not two objects pointed at the same memory address. Right? That's a shallow copy. Yeah, so this one, almost all the time true. So I expect people to say true here, because we almost always want a deep copy, because otherwise it's not really a copy. Like shallow copies aren't actually copies. So yes, this would be true. We always want the deep copies, because we want to avoid having two objects pointed at the same location in memory. Bad stuff can happen. Right. How does polymorphism allow you to create subclasses as their superclass type? Remember, that's where we had have recent projects. Oh, it's not even in my recent list. That's all right. It's probably in the GitHub repo. Not that one. This one here. 51, summer. So that was chapter 10, inheritance. Remember, we're able to make this array list of type polygon. Here, let me zoom out a little bit, sorry. Ooh, whoa, too much. We had an array list of type polygon, and we could put objects that were polygons through inheritance in that array list. We can treat them as their parent class type. Because it lets you treat an object as its parent class as long as it's a subclass. That's what polymorphism lets me do. It lets me treat them that way. So what you don't get the additional methods. Right? So if you add a new method, it doesn't work. But if you override a method, you'll get the overrided behavior. So we saw when we did all those printings, not chess, this one here. Right? All of our gets here, we would get the correct values back out. So we have like get area, was it? Is that get area? And circle, we did rectangles and squares. Let's see. We look at rectangle or square. So we overrode get area here. We implemented it really because it was abstract at that point. I think we left it as abstract for polygon. Yeah, we let polygon to be an abstract class so we could get area out. So polymorphism lets me treat them as their parent class type, and I get any overridden behavior. Right, inheritance creates an is-a relationship between the parent and child class. That one's true. Number 11, the equals method can be used to compare if two instances of a class have equal values. This one's a bit of a trick question here. So I'm assuming this one is false because it doesn't check values. It can be used, though, if you write it. So if you write your own equals method, you can then compare if two instances of a class have equal values. But by default, it does not. So I would assume this one's false. Here, it's a little bit tricky because it can if you do it. But the catch there that it doesn't do it unless you make it. So I can't compare two instances of food unless I add that equals override or add an equals method. Right, when designing a solution to a problem, any nouns are potential classes. That's true. Right? Anything that's a noun, it could be a class. It doesn't have to be, but it could be. Typically, the attributes of that noun, right, are all of your instance attributes. Right? All the things about that class, all the things that it knows about itself are its attributes, and the ways that you interact with the things that it does, its verbs, are typically the methods. Not 100% of the time, but that's typically how we go about designing solutions, because we like that. It's a nice object-oriented approach, and people like objects. Boxing and unboxing, remember that's the wrapper classes for primitive types, so int becomes an integer, or integer becomes an int, whether or not we're boxing or unboxing. You can treat classes that implement interfaces polymorphically by their interface type. You sure can. That's what we did up here with this interface type, the has volume interface. We said, hey, let's make an array list of has volume interface type. Sure, anything that implements that interface we can throw into this array list because it is one of those. So with implementing interfaces, you still get the is-a relationship, but you can implement more than one interface. You can only extend from one class or inherit from one class. You can also check to see, hey, is it assignable from? which is pretty cool. So as we're going through our polygon, our shapes here, right, we can go do something with it here, which is fun. Right, private variables in a superclass can be accessed directly by the subclass. Is this one true or false? If the variables are marked as private. That is false. That's correct. It needs to be marked as protected if you want access to it. Protected variables in the superclass can be accessed directly by the subclass. Or just private variables cannot be. All right, one last one. If you have 100% code coverage in your unit tests, you're guaranteed a bug-free program. As much as I love code coverage in unit tests, unfortunately that's false. Right? Nothing guarantees that it's bug-free. Just because we tested it doesn't mean there might be something we didn't test for, that we didn't catch. Because we're not perfect. We make mistakes. Okay, and then the long answer questions. Write a class Sunday. Sunday has an array list of type string to store the ingredients, an integer value for number of scoops, a double for cost per scoop, and a double for price per extra ingredient. Add a method add ingredient that accepts a string value, adds it to the array list of ingredients. Add a method get total cost that returns the cost per scoop times the number of scoops plus the cost per ingredient times the number of ingredients. Oh goodness. Okay, we can do that. Right? Cost per scoop and a price per extra ingredient. We're going to write our Sunday class. So we start up a new project for this, I guess. We'll do a midterm review project. How about that? Midterm review in 2151. Right, close that one. Gotta remember to close projects here. Save it. All right, so we're going to add a class for Sunday. All right, so we had an array list of type string for ingredients. We had a double for cost per scoop. We had a double for cost per ingredient. Or was that ingredient? Yeah. Integer for number of scoops. Okay, int for number of scoops. Number of scoops. Double for cost per scoop, double for price per extra ingredient. Array list to store the ingredients. All right, a method for add ingredient. A method for get total cost. Sure. All right, so how about we make a constructor first? And again, let's let this do it for us here. So let's make a insert code, insert a constructor. We don't need the ingredients yet. How about you tell me the number of scoops and the costs here when you make one, and then we'll go add some ingredients after. I'll take my ingredients equals a new array list. Oh, we have to add our import here. There we go. Add the import. Okay, so you tell me the cost per scoop, cost per ingredient, and the number of scoops. I'll make your Sunday, and then I can start adding ingredients. So we have a method for add ingredient. Add ingredient, string ingredient, ingredients.add, ingredients.add the ingredient. Okay, and then a method for get total cost. So double get total cost. All right, well, we need to be the cost per scoop times cost, right? So cost per scoop times the number of scoops plus the cost per ingredient times the ingredients dot size. Right? Cost per scoop times the number of scoops, cost per ingredient times the number of ingredients. Great. There's our Sunday. And then write a unit test for get total cost. All right, so right click, navigate, go to test. Sure. Make sure we're using JUnit 4. If you don't need any of these other generated code things checked, don't worry about it. And here's our test. So test some method. Oh, sure, we want test get total cost. Total cost. So we're going to arrange, we're going to act, and we're going to assert. So we're going to have a double for Cost per scoop is what? I don't know. What do you want to do? About $1.50. We'll have a double for cost per ingredient. How about 50 cents for those? And int number of scoops. How about 3 scoops? And then what's our expected cost? So expected cost. So if we have 3 scoops at $1.50 a scoop, and we add some ingredients, we're at $4.50. How about we add 2 ingredients? Should be $5.50. Right, then we'll act. We'll actually make our sundae. So sundae equals a new sundae. And then it needs, oh goodness, what's the order? Cost per scoop. Cost per scoop. Cost per ingredient. And number of scoops. And then we'll go add 2 ingredients. Add ingredient. How about we add whipped cream? Sundae. And we'll add some fudge. Hot fudge. Okay, and then we'll have a double for actual cost. Is my sundae. That get total cost. And we'll assert, do they match? We'll assert equals the expected cost and the actual cost. Now, anytime you're using doubles, though, we want to be a little bit careful because the math doesn't always come out right. Is it assert equal? Equals? Oh, equals. Okay. This should work here. I thought we had the delta, but that's fine. Let's give it a run. See if our test works. Uh-oh. It's telling us assert equals is an expected, an actual, and then a delta to compare floating point number. So how close is close enough? Like within a penny is probably close enough here, right? Or within a tenth of a penny? Sure. Let's give that a run. There we go, and now it passed. So we got $5.50 out for our expected cost for our little hot fudge sundae with 3 scoops. That's a good ice cream there. Right, so you could just copy paste in both for me. You could copy the sundae class in and then the test, or you could commit it to your repo and give me the link to your repo. Either one's fine with me. The text boxes are pretty big here. It's usually pretty easy to add them in here. All right, so again, the goal here is that one takes, maybe 20, 30 minutes, and then you've got twice that if you need it. Right? If you're, aiming for an hour per long question and then an hour for the short answer quiz style questions, that gives you 4 minutes per quiz style question. Just kind of pacing yourself here. Okay. Write a function cipher that takes each character in the string. If it's an even index position, add 1 to the character value. If it's an index odd, if the odd numbered index position, subtract 1 from the character value. So I have to pass A and get back B at B. Remember those Unicode values. We'll write a function here for cipher. Public static string. Oh, is it returning a string, right? What does it do? Yeah, it's going to have to return a string because strings are immutable. So we'll have to return a string cipher. Given a string, I don't know, word. Okay, so we're going to have a string result. Starts off as empty. And then I want each character in word. Right, so can I loop through? For int index is 0, index is less than word dot length, right? You get the length of a string. Index plus plus. So if my index mod 2 is 0, that's if it's even, right? Divide by 2, if it divides evenly, if there's no remainder, remember modulus is the remainder, if there's no remainder, it's even, we're going to add 1 to the character value. We need the character app, so I want my word dot char at the index. And that'll give me an individual character. I want to add 1 to that. And I want to take that to my result string. I want to append in there all of that. Otherwise, right, if it's not, then I want to do the same thing, but minus 1. When I'm done, I'm going to return result. So take the string, go 1 character at a time, Right? If it's even, add 1. If it's odd, subtract 1. So let's cipher for AAA. Then we'll print out cipher AAA. Let's see what we get. Oh my goodness, my reinstalling made this really sad. This NB Java C plugin just did not want to work. Run it again. Uh-oh. Uh-oh. We're getting numbers. 66, 64, 66. Right, well, give me the number. I want it to be a character again, so I need to turn it into type char. Right, cast that as a char. Here. Right, turn it back into a character after I do my arithmetic. There we go. Now I get B at B. Right, we can do all sorts of fun things too, right? Eric. It's just a little shift to the letters. FQJB. That's Eric, right? Now this one isn't even to let us undo it easily. We could undo it though, right? We could undo it. So here's the string result. You know how we undo it in here? Right, we'll print out the result. Well, to undo it, we need to take my string result, or my result, equals space plus result. I'm going to string new result, cipher result, new result, and we want a substring from 1. Right, take out that first character. So add in the space to shift everything from even to odd, and then take out that space we just added. Right, because evens go +1, odds go -1. So if I add a space, then all of my evens are now odds, all the odds are now even. We'll undo that little cipher here. And I can just take out that character. That's just for fun. Wasn't anything we needed to do, sorry. I just got excited. Okay, so just playing with strings. Right, and then let's extend that class stuffed animal. When making a noise, if battery has power is true, return a string that includes the name and the appropriate animal noise. Otherwise, return an empty string. Generate a random number between 1 and 10 after making a noise. If you get a 1, set has battery power to false. All right, so we got to go back to our midterm review. Here's the class here. We go copy paste this. Yeah, it's already in the right package, midterm review. So we go add a new stuffed animal class. Class stuffed animal. Okay, so here's the abstract class, right? So it has a boolean for battery has power. It has a constructor that takes a name, sets power to true, has the value for name, a get name. It has a change battery power, which sets battery power to true, and then a does battery have power, right? It can check to see if there's power, and then the abstract make noise. We're going to go extend this class. So how about we make a stuffed dog? And stuffed dog then will extend stuffed animal. That extends stuffed animal. And then it tells us, no, it doesn't. So yeah, we need to implement the abstract method. Well, what is make noise? All right, so we need to call we need a constructor, stuffed dog, that accepts a string for name, and it calls my superclass given the name. Right, so call the stuffed animal constructor, give it the name. So if it's Fluffy, we're going to pass in Fluffy. Right, and then for make noise, we need to, oh goodness, sorry, that's the wrong button. If battery power is true, we return a string that includes the name and the appropriate animal noise. Otherwise, return an empty string. Okay, so first we're going to check. So we're going to say if battery has power. Why is it unhappy? What am I missing here? I got it really confused. Let me just maybe build real quick. Ah, I have too many braces here. There, now we're happy. Okay. All right, sorry. So if battery has power, right? Battery has power is a protected Boolean, so we have direct access to it, right? We don't even need to use the methods. Either way is okay because this one's protected. If it was private, we'd have to use the methods, right? So either one's okay for us. So if battery has power, then we're going to return what? Get name. So name is private though, right? So the only way we get the name is through get name. So get name plus goes woof woof. Otherwise, we're going to return just an empty string. Oh, sad. We ran out of battery. And then we also need to check, right, to see, hey, generate a random number between 1 and 10 after making a noise. If you get a 1, set has battery power to false. So we need to get a random number. So random equals a new random. And then if random next int 10 equals a 1, right, generate a random number. So 10 actually gives me 0 to 9, but it's the same thing. We're only checking one of them. So this is okay. So maybe you'd want to do +1 to get 1 to 10. Maybe it's perfectly in line with what I asked, but that's okay. All right, so if it was a 1, we're going to say battery has power equals false. We'll set it to false. Or we could use the method. Right? Either one's okay. And then we'll give them back, Fluffy goes woof woof. Because this is a stuffed dog. Okay, and that's it. Right, one from chapter 8, one from chapter 10, one from chapter 11. So 8, 10, 11. So 10 was inheritance, 11 was exceptions and file I/O, and 8 was, oh goodness. Should remember my chapters. That was the second look at classes, right? It was 8. Yeah, second look at classes and objects. So we weren't going to do the text processing and wrapper classes. So like that string question, don't worry about it. So classes, inheritance, and exceptions and advanced file I/O. Probably ask you to read or write a file, that sort of thing. Okay? Questions, thoughts, concerns? There wasn't too much tonight to finish up here for exceptions and file. Again, it's going to take practice. You want to get in and try it, get into working on your project, see how that goes for you. Right? You need to be able to write the file before you can read it. So make sure everything's serializable and go write it. And then you should be able to read it, and it should populate back all your objects when you read from the file. We okay so far? How you folks feeling? And we got the midterm next week. So again, you'll have all 713. It does have a 4-hour time limit. And then the project wasn't going to be due till when? But got a little extra time on that one, right? Yeah, till 7:20. So that won't be due till the week after the midterm. So if you want to focus on the midterm, great, and then come back to the project, that's cool. If you want to get the project done and then do the midterm, great, then you got a week off. Whatever's going to work better for your schedule there. Okay. And when we come back on 7:20, we'll pick up with Java FX. A little bit of review in case you didn't do a whole lot with it in your previous 1500 class. So it might start a little slow, but then we'll get into some more interesting stuff. Graphics, effects, and media is really cool. And then we'll start the final project as well. Remember, that is big. That's 40% of your overall score. I highly recommend you work in pairs on this one. I'm not going to require it given the crazy remote learning stuff we're doing. But, usually you'll get a better product if you're working with someone else. Okay, you can bounce ideas off of them and you can catch each other and just help figure out how you're going to implement everything you need. All right. That's all I got tonight, folks. So we got a little extra time to work on the project, do the other midterm review, whatever you need. I'll be around tomorrow for office hours. Someone's meeting me at 3, so I've got like 3:30, 4 open as well, or tomorrow between 10 and 11 are open as well. If you can't make the regular office hours, let me know. I can see if we can schedule something off those regular times. All right, it's been fun. Let's see who else is around in Twitch land and go send a raid out their way for fun. We'll say hi to somebody else doing some fun stuff. Ooh, physics. Can I go do some physics? Let's try that. All right, friends. Take care. I will see you in 2 weeks then. Unless you have other questions, thoughts, or concerns, let me know how I can help. Take care, everybody.